today is in short, basically, because last time we have studied the LSTMs and sequential models. So today we are going to know about the sequence to sequence model. You already know the sequence to sequence model. You are very well versed with this one, but still, this is very uh, uh, came in 2014 by Google, and it was very popular at that time. So what it did was input was a sequence of characters maybe or anything, and output is again a sequence. So whenever you want variable length input, variable length input as input, variable length sequence, and variable length output. So this length of input and output may vary, does not is not constant. So this sequence to sequence model, when this came in 2014, it was very popular. So at that time they utilized the concept of again GRUs and LSTMs. So because these two networks were sequential models, and they allow to process the sequences using uh, they allow processing sequences and storing the past information using memory. So memory, concept of memory was there. So in sequence to sequence model, basically, so we before looking at the uh, uh, architecture of this one. So it's basically encoder and decoder architecture. Application can be, it is used in translation, machine translation, and this machine translation is in your syllabus. So we will have a look at this machine translation part into detail. Also, it is used in so many other applications, maybe like text summarization and maybe image captioning and so many other options. Wherever you have a variable length input and variable length output. So whenever you have variable length inputs and outputs, you can use a sequential model. Now let's have a look at the architecture. So uh, before before studying the architecture, we want to recall what we know about GRUs and LSTMs, because sequence to sequence utilize these models. So disadvantages of RNNs. So let's have a look at limitations and sequential models. Sequential models. So for RNN, positive point was we are able to process the sequence. Negative point was vanishing and exploding gradients problem, right? Vanishing gradient and exploding gradient problem. So to avoid this, GRU and LSTM came. So vanishing and exploding gradient was solved somewhat, but what was the disadvantage of these two? Unable to process very long sequences. So for very long sequences, gradients was lost. In case of very long sequences, these are not able to solve this vanishing gradient and exploding gradient problems. Also, the problem was attention to a particular word was not there. So then came the attention networks after this. So because in a whole paragraph, if I'm talking about a book in a paragraph, so that book, name of that book should be given more attention, and or maybe that a particular item is to be given more attention. So so significance of word is lost. Second disadvantage of these models was, suppose we have a very long sequence, and in the last sequence, the last word, whatever is the last word, this was given more value, because if you keep on multiplying, so it gives more value to we have discussed this thing also in the last class, like it gives more values to whatever comes recently instead of whatever comes in the very previous to the word that we are predicting. Okay, so this was a disadvantages. Now these two disadvantages, because sequence to sequence models utilizes the concept of GRUs and LSTM, so these two disadvantages lies with the sequence to sequence model. So let's have a look at the architecture of sequence to sequence model. So in sequence to sequence models, we have an encoder and we have a decoder, just like a simple encoder decoder architecture. An encoder is made of RNNs and RNNs or maybe any sequential models, and decoder is similar to that. So what happens in a encoder decoder architecture? Uh, we have maybe GRU or RNN cells, and then this will generate a representation, and then this will create a sequence. Now this sequence can be shorter or larger. Suppose I'm inputting a English sentence, hello, how are you? Suppose I'm writing how are you, and here it will be translated to Hindi. So in Hindi it might be having 4, 5, 6 words, multiple number of words. Okay, so the architecture, so varying length inputs sequences can be processed. So architecture of sequence to sequence is nothing. It's just encoding the whole sequence into a representation, and then putting this sequence as input and the first word, maybe the start word, as input, and it will generate the whole sequence. It will give you output. Then whatever it gives, you give it over here, it will give you next word, whatever you give over here. Okay, and so because in RNNs you have, at every cell you have two inputs. One that is coming, that it is processing the current input, and second that is it is coming from the previous activations, right? So at every point you have two inputs. One is, so for this you have this represent intermediate representation, and this intermediate representation is generated from this whole sequence, which is your encoding part. So this is encoder and this is your decoder. So this is a simple sequence to sequence model. So nothing too much complicated about this. I have also seen the diagram for this. Yes, so this is, they are converting it into, from a set of words from one language to another. They are, uh, decoding it to another language. So this is the overall working of a sequence to sequence model. So this is simple example of a machine translation. So in upcoming lectures, what we will do is we will have a look at machine translation in detail. We will check out statistical and neural machine translation. Okay. So this was it for today. We are not getting into much details. You will find this, because this was developed by Google, so you will find everything about it on this GitHub for this one. Okay.
Ma'am, so basically the input has a different set of vectors, and the output has a different set of vectors which translate into different languages.
Right, exactly. So input is, suppose my word was hello. So this would be, hello would be encoding or maybe embedding for hello would be 0, 1, 0.5 something. A vector is there. This vector will be given as input over here. And then it will generate some activations. And then for how I will create a embedding set of vector. And then this will be, passed to the next maybe cell. Okay, and then for R similar thing, and then for U similar thing. Now there is one more thing. Suppose in your data set you have variable length sequences. You have 3-word sequence, you have 4-word sequence, you have 5-word sequence, you have 10-word sequence. Now how you will pass this whole to a LSTM architecture, because this architecture you have made the constant number of cells you have made. Basically you have made number of time steps. So this is time t is equals to 1, time t is equals to 2, and time t is equals to 4. Okay, so you want it to run for t up to t equal to 4. Now so you can pass only 4-word length sentence, right? So for 3-word, what we do is we can add some maybe zeros or something like that over here. And for lengthy sequences we can truncate it, or what we can do is we can increase the time steps to the maximum length sequence in the data set. So maximum length was, let's say, 10, so timestamp would be 10. But in that case what would happen is this architecture would become slow, learning would become slow, because most of the time it's learning 0 0 0 zeros, because first sentence, most of the sentences were 3 or 4-word length. and one sentence was 10 word length, so you cannot make the architecture with that with respect to that 10 length sequence, right? So for that you truncate that sequence. Okay, so there are many methods for doing this truncation, leading and trailing parts for the sentences. So you can use any of the methods. Okay, so generally what we do is we check the average length from the whole data set, average text length, and according to that we decide the architecture of the model. And whenever it is giving something out, something as output, so whatever it is giving as output, this is the intermediate representation, and this representation plus the start symbol over here is passed as input to the first cell, and then it will give you some output. That output is passed to the next cell, and this is how text is generated. So this is the example of machine translation. You are translating from one language to another language. Okay. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. So this is sequence to sequence. Uh, in sequence to sequence, or in a simple neural network, you could know. For example, suppose you want to use machine translation. You want to do machine translation with a simple neural network. So what you will do, you will generate these feature vectors, and you will pass all these feature vectors as an input in the first layer, whole set of vectors in the first layer, and then you will add another layer, multiple layers you will do, and then you will generate some output, you will back propagate. Okay, so this is so in next lecture we'll see how you will do this with a simple neural network. Right now we are just seeing the sequence to sequence. So in sequence to sequence we are taking the input from the previous timestamp also. Okay, so because we are not treating all these words as individual feature vectors, we are taking input from whatever it was coming from the previous word also. And you can see that while decoding, so this last word will be having activation 0.1, previous one would be having something multiplied by 0.1, so it would be definitely lower. So as we go on, so recent words will be giving more attention, or not attention, we can say the whatever the representation, intermediate representation, this whole encoder sequence is generating. So whatever it is generating over here, so the most recent word will be having more weightage in respect to whatever that comes very early in the sequence. So this is a disadvantage of this LSTMs also, and this sequence to sequence also, that the word, if for a if very long sequence is there, so word that is coming very much previously in the sentence, so that word is not giving much weightage, even if that word is very important for the language. So that is why attention model came, and in attention model, the word which came very earlier, or some words are that are very important for the whole paragraph or for the whole sentence, so those words are given more weightage. We'll see how attention and transformers work in the upcoming lectures. So this is sequence to sequence. So that is it for today. Not much. Any questions or anything? Okay, I guess. So